All right, so let's start with 30 degrees, and you know my philosophy. If you know 30, you know them all. Okay, if you know 30, you know them all. So what's the coordinate at 30 if I'm on the unit circle? 1?
3/2 and 1/2.
Radical 3/2, 1/2. And then from here, we should pretty much know the rest. If that's radical 3, 1/2, I also know 60 because I do what with this coordinate? Flip it. So 60 now is going to be 1/2 radical 3/2. And 45, same coordinate, which is what? Radical 2/2. Same thing. All righty? So let me go to third quadrant now. How do I tackle 240 then? How do I tackle 240? Because I don't want to memorize it. First thing you find, Jared? Find the reference angle for 240, and it should be 30, 45, or 60. I'm not going to give you a reference angle that's not one of those three. That's not how this works. All right, your reference angle will always be one of those three. And anybody, what is the reference angle for 240? 60 degrees. So 60, 1/2, radical 3/2. The only thing you got to do now is I'm in the third quadrant, though. So what do I know about the x coordinates and the y coordinates in the third quadrant? They're both negative. That's where you got to be. Okay, that's where you got to be. And then you are responsible for the 4 more, though. The quadrantal ones on the line. So 0, 360, what's that coordinate again? 1, 0. Oh, 180. Oh, 3 off. 180. Negative 1, 0. 270. 0, negative 1, and then up at 90. 1. I know it's going to come up today, so let me review it real quick. How quick can we do it? Pi/2 degrees.
30. 90.
Thank you for saying this. Thank you. 3 pi/2. Pi. 2 pi. Okay. Just those will come up again. All right. So everyone all right with their coordinates on the unit circle? Because today we're actually going to do something with the x coordinate of one of them and the y coordinate of one of them. They're going to have some special meaning here today. The actual coordinates by themselves. Anything else? All right, you ready to roll? Last period, got through the notes and the assignment, still had 10, 15 minutes remaining. So hopefully it'll be the same here. All right, still working on the unit circle. So what I did on this unit circle I've given you, I made a right triangle. Hypotenuse is 1 still because we're on the unit circle. Hypotenuse is still 1. I didn't want to label the 2 legs, so I just called one leg X and one leg Y. All right, and I put a theta in here because I want you guys looking at that angle for these 2 problems. Okay, look at that angle. So the first question comes up is find the expression for sine of that angle, sine theta. All right, we're going to use that right triangle to find what sine theta is equal to. And we're going to do that by going back a couple days ago when we used SOHCAHTOA. Okay, SOHCAHTOA. So all I want from somebody whose number comes up, what is sine equal to if you look at SOHCAHTOA? What 2 sides do I need if I'm going to find sine? 12, what 2 sides do I need? No, 12? 12, hi Sydney, how you doing? Good to see you back.
The opposite.
Good job. Opposite and the hypotenuse side. All right, let's keep going. Remember, I'm looking at angle theta right now. So what can you tell me is the opposite side? What is the opposite side of theta labeled as? 10, what's the opposite side of theta labeled as? Is there a 10?
I thought it was 9. Would it be y?
Y over, how about the hypotenuse of this triangle? 1, yeah. So that sine is equal to y over 1. And can you simplify that a little more for me? The sine is just equal to?
Y.
The y, yeah. And I'll tell you why that is so huge here in a second after we do the same thing, but for cosine now. Let's do the same thing, same triangle, same angle for cosine. What two sides do you use to find cosine? 15?
Adjacent, hypotenuse.
Okay, so adjacent over hypotenuse. All right, what side did we label as adjacent? What side did we label as hypotenuse? 10. What side did we label as the adjacent side to theta?
Would be the 90 or the 1? No, 1's the hypotenuse. X.
X. You good? And what's still the hypotenuse there?
1.
1.
So then it would just be X.
So the cosine is just equal to X. So what am I trying to tell you here? All right, what am I trying to tell you? Let me use an example to show you what we just found out. All right, let me give you an example. The sine of 60. Everyone type that into your calculator, please. Sine of 60. And everyone's getting a decimal, right? That says 0.866. Leave that decimal in your calculator, okay? Here's what we just found out. We can use the unit circle to find the value of sine of 60. 60. Somebody tell me the coordinate. What's the coordinate at 60? We just reviewed it. Coordinate at 60 is what? Oh, my heart. 1/2 radical 3 over 2, right? And I just asked you to find the sine of it. And what we just figured out was the sine is the same thing as the y coordinate. The sine is the same thing as the y coordinate. Which one's the y coordinate out of the two? Go in your calculator right now. Do the square root of 3 divided by 2. Same thing. Okay? That's how we're going to use this now. That anytime it asks me for the sine, I'm going to go to the angle and pick off its y coordinate. If it asks for, ready? Let's do this. Cosine 45. What's, okay, at 45 degrees, what's my point from yesterday? Radical 2 over 2, comma, radical 2 over 2. And we just found out if you ever want to find the cosine of any angle, you take the x coordinate, which is what? You can't be wrong here. What's the x coordinate?
Square root 2 over 2.
Go to your calculator. Do cosine of 45. You'll get a nice sloppy decimal. And then do radical 2 over 2. Yeah? Okay, let me do one more here with you to see if I can drive this home. What do you want, sine or cosine? Cosine. 270. Oh, where's 270? Ready? Think 270. What's the coordinate? Think 270. This is all our work. This is all the hard work we did yesterday. 0, -1, and since I'm finding cosine, that's the same as what coordinate? The x coordinate, which is?
0.
Check it. Cosine 270? 0. So do you see how we're using the points now on the unit circle? Anytime you want the cosine, you take off which coordinate? The x, and anytime you want the sine, you take off the y coordinate. Okay? You just got to make sure you're at the right degree measure. Yes? No? Jared, what's up?
I don't know. I'll
Talk
get
to
the
me.
hang of it.
What's
It's
that?
fine.
No.
No,
Talk.
I'll get the hang of it. It's
Okay, can we get, well, let's do some more examples and we'll see where you're at, where your head's at. Big celebrity too, huh? I saw your nice little Halloween edition of the news. It's like, hey, he's in my class.
Yeah.
I feel so honored. Yep, I feel so honored. Good. It's also great because you got a celebrity teaching the class too. So
Yeah.
we can relate because two celebrities.
A-list. So.
Yeah. (2009), Jared, PBS, hour and a half Regents review on geometry. This guy, all throughout New York State.
2009.
Maybe 10. I can't remember. Yep.
How much did they pay you?
There was a decent amount. I'm not going to say how much, but yeah, I had to audition for it. And
Oh, really?
yeah. Yep. We did an hour and a half of the reviewing for the geometry Regents in June.
Did you
Yeah.
include slang then?
I don't think I did, and I think I kept it professional. Yep, live too. Call in. Students could call in and ask me questions from previous Regents exams. Yep. Yeah. Just saying.
What made you
I
want
want
to
to
do
look
that?
this up.
I don't know, to be honest. It was just I saw an email went out to all the math teachers, and I was like, you know what? Why don't we try this out? And yep, brought them right in. Yep. Go ahead. Yeah, we got time. So here you go. And you think you're famous? Wait till you see the amount of hits on this bad boy. Where is it? Video. I don't want my own YouTube channel.
Play the guitar.
No, that's not any of me. It must be another one. Regents review. There he is, the young gun back in the day.
I think we should watch a little.
Part 1. Yeah, I don't know where parts 3 and 4 are. I just know where parts 1 and 2 are.
How many views did you get?
18,000.
Oh, yeah, can we just see that number right there?
Wait, what's that?
Can we see that number right there? 18,453. Just throwing that out there, everybody.
This guy sucks.
This
No,
guy you have right in
no,
front of you right now,
no
teaching this
dislikes.
class.
Scroll down.
Yeah, scroll down to the comments.
Well, there's some. Yep. Hey, just wanted to say thanks for putting up these videos, and I hope you put up more. You really gave me some awesome tricks to teach my students. I'm appreciative. Darn right.
Did you get a new
Yeah.
fan letter?
No, I did not. But yep, and I'm watching this. 5 into geometry Regents instead of watching my other geometry video by John Carlino. Yeah, good.
Videos, that's it.
Yeah. So you want to talk celebrity? Look at that young buck. Huh? There you go.
Yeah,
All right. So there you go.
Whoa,
All right.
these old sets.
Yeah. What do you think? I was joking around. PBS, bud. New York State. New York State.
You look
All right.
like the slam chop guy. You know what I'm talking about?
All right. So there you go. Don't know who you have up in front of you every day. All right. Yeah, my claim to fame back in 2010. I go in supermarkets. Oh, that's the Regents guy. Not really, but that's what I tell my wife. All right, here we go. So where am I going to use all the sine? The sine is equal to the y value. Cosine is equal to the x value to start solving some of these problems. So look at part A. I don't want to fill in the chart yet. Let's look at part A. Find the number value of f of pi. Now this is going back to your Algebra 2A days from last year. F of pi if f of x equals sine of 2x. So if you guys remember, anywhere I see a what, I want to plug in a pi now. An x, right? So really I'm asking for, hey, can you guys find me the value of sine of 2 pi, right? Sine of 2 pi. Well, that's in radians. That's in radians. What's 2 pi in degrees again? 360. So I'm asking you guys to help me find what is the sine of 2 times, or sine of 360. Because 2 pi equals 360. All I did was convert to degrees. Everybody ready? All right, I get it. You could use your calculator for these. Some you can't, though. So let's try to do this by hand. 360. What's the coordinate at 360?
1, 0.
1, 0. And I'm asking you guys to find the sine. So we just figured out, oh, you want me to find sine? Which coordinate do you use?
Y.
The y coordinate, which would be what out of these two? So the sine of 360, 0. And yes, you could check it on your calculator. Is everyone all right? Why I'm taking 0 versus 1? Why I'm going to 1, 0? Because this is 360 right here. All right. Next up, cosine pi over 2 plus 2 sine 0. Ooh, pi over 2? I'm not familiar with that. Pi over 2? Pi over 2, come on. 90, so ready? Cosine 90 plus 2 sine 0. You can do this. 90 degrees, what's the coordinate? 90 degrees, what's my coordinate? I got to know it to do this problem. 0, 1. And if I'm told to find cosine, which coordinate do you use?
X.
The x, which is?
B. 0.
0. So cosine of 90 is 0 plus 2 times the sine of 0. Now I go to 0 degrees. I already put the coordinate there. Which one do I want, the x or the y? If I'm finding sine of 0, which one do I want? The y coordinate, which is?
0.
Everyone all right where I'm getting these values from? And why I'm picking an x versus a y? So the final answer here will also be 0. The next one will not be 0, I can guarantee that. Ready for the last one? Negative 2 cosine 180 plus 3 sine 270. Ready? Negative 2. Let's go back up to my graph. Anybody remember the point at 180 now? 180, negative 1, 0. And if you guys are finding cosine, which coordinate do I want? The x, which is? Negative 1. So I'm going to say negative 2 times negative 1 plus 3 times, I got to find the sine of 270. That's the only one we haven't done here. 270 was 0, negative 1. And if I'm doing sine, which coordinate do you want again?
Y.
The y, which is what? Okay, see how this is working now, Jared. Any better?
Yeah.
All right, good. So let's keep going here now. What's that? 2 minus 3? So negative 1 is my final answer there. Any questions? Because now I want to get off the quadrantal angles and go 30, 60, 45 now and do the same thing. All right, here we go. Whew. Anybody big weekend plans going? Okay, just checking. Just going to be, everyone's going home today, going to be balled up in the corner of your room waiting for Monday. Wishing you had plans. What's that? Going to roll into the club afterwards with the boys? VIP style. I get it.
Clubbing
Yeah. You never know.
There's one club in Delmar.
Is there?
Yeah, it's on the maps, but it's a random house, so I don't know how to club.
Like, club?
I mean, that's what it said. So, do you often?
No, the
Back
Mr.
when-
Mr.
back in
Carlito's
2013.
clubbing days was a while ago. But yeah.
Montreal when you were 18.
No, I never did that. No. I'm a role model now, so we don't need to bring up the past. You know. The gel back hair, the spiked up hair, the earring, yeah.
I can see you having
Yeah.
frosted tips.
Yeah, hoop too, right here. Right there.
You had
Badass.
you had frosted tips too.
No frosted tips. Just took the gel. I had a longer hair back then. Put the gel up a little bit. Yep. All the cologne. Yeah, great. Yep. Took the Axe bath. You guys know what I'm talking about. All right, let's be real. Okay. All right, moving on. I got to make sure we are good on one of these on the directions. All right. What is the exact value? This drives me nuts. So I want to make sure we have a clear definition of what an answer should look like that is an exact value. When it asks for exact value, it is looking for the following. I want fractions, radicals, or both in your answer. All right, fractions, radicals, or both in your answers. Notice what word is not there. No. Yeah, darn right, Sydney, decimals. All right, I don't want decimals because look, for example A, could you just go sine of 30 in my calculator and it gives you a 0.5? I don't want that. Okay, I don't want any long sloppy decimals ever. So this is why I'm forcing you to know how to use your unit circle. Sorry. 30. Name the point at 30. Come on, we worked our tails off yesterday. 30. Radical 3 over 2, comma. All right. And I'm asking you to find the sine. So what coordinate do I want out of those two? The y, which is? You're done. The sine of 30 is 1/2. Now, can you use your calculator to check? Absolutely. But I don't want the decimals there. I want radicals, fractions, or both. Ready? Sine of 45. Radical 2 over 2, radical 2 over 2. You can't go wrong here, but I'll ask anyway. Sine, which coordinate do I want? And even if you forget, you can just, the y coordinate. So radical 2 over 2. Again, go to your calculator and do sine of 45. I just want to make my point clear. What I do not want is answers. And what I do not want is that decimal that's staring you in the face right now. Now, can you check to see if you're right? Yeah. Everyone right now do radical 2 over 2 in your calculator. Square root of 2 over 2, and those decimals should match. So you can use your calculator to check. I just don't want that sloppy decimal up on the paper. And then finally, cosine of 30. We got 30 already up here. What coordinate do I want, though? The x. So what's the cosine of 30 equal to? Square root of 3 over 2. Monday, we'll start going into the other quadrants and do like cosine of 210. All right, cosine of 300. That'll be Monday. But for now, I just want you to stay in the first. Last question. Nobody knew this last period, and I totally blanked. I think I know. Anybody know what that Greek symbol is? Like we've had what? We got theta this year. We've had beta.
Is it alpha?
I think it's alpha. Anybody?
Does alpha have the top thing as well, or is it just in
I
down?
have no idea.
No.
I'm not up on my
Women
Greek.
frats?
No, actually, I was not. Sorry. No, shocking. Yeah, after everything we've talked about today.
Max Baths alone out the frat boys.
Do more than math in here. I think that's it, right? Yeah.
Yeah.
Alpha, lowercase, yep. Got it. What else we got?
We should just do this.
Delta, yep. Epsilon, zeta.
Oh yeah, we should do this instead of numbers.
Yeah.
You got it. What was yours?
Omicron, wasn't that COVID? All right, there you go. Well, Greek alphabet history. So we got alpha there. Okay, all it means, again, you guys know, it just means an angle. All right, a different way to represent an angle. And the terminal ray goes through negative 0.6, 0.8. Okay, but here's the huge part. This is the key to the whole problem. This point is on the unit circle. So that tells me, oh, I got a point on the unit circle. What's the x coordinate represent? The cosine And the y coordinate represents the
Sine.
sine, because I'm telling you this point's on the unit circle. X equals cosine, right? Y equals sine. So this makes this problem pretty darn easy now when I say, which of the following values is the sine of this angle? What coordinate do you want? The y coordinate, which is 0.8. Okay, 0.8. Questions? I need you to do one last thing. Go back to your unit circle diagram from yesterday. Just to wrap this all up before you go to your assignment. I want you to look at all the coordinates we wrote all the way around. Look at all the coordinates. I want you to find the highest coordinate, the biggest coordinate, and the smallest coordinate. Okay, like you wrote 1/2 radical 3/2. Is there a number bigger than 1/2? Is there a number bigger than radical 3/2? I want to find the biggest x value and the biggest and the smallest x and y values you put on your unit circle. So look at all the coordinates that you put on. What's the biggest number and the smallest number that's on there? Just so I can make a point before we leave. The biggest coordinate and the smallest coordinate. Not the degree measure. The biggest coordinate and the smallest coordinate. Anybody? What's the biggest one? The highest coordinate it goes up to? Jake?
Would it be 1 and -1?
1. All right? Anybody see a bigger number than 1? You got that? Sure you did.
I'm fine. I'm serious.
All right. Anybody see a number bigger than 1? Anybody see a smaller number than -1? Me neither. What am I trying to tell you? That the biggest one is 1 and the smallest one is -1? When we go sine and cosine, you should never get an answer bigger than what? 1. And you should never get an answer smaller than -1. So remember that as you move on and do the assignment today. All right. If you get an answer of 2.6, something went wrong. Okay, because the highest value it could possibly be is 1. All right, all good? All right, go start the assignment. Get a Chromebook out so you can see the answer key too. Chromebook's out. Answer key. Go ahead. That was a little bit longer discussion.